Welcome everyone. This is Dr. Wortel with a discussion on Worksheet 10. Let us start with the first question. So we have a rectangle and we have to compute the following integral into two different ways. So in this case it's easy, but in general it's always useful to make first a quick sketch of the region. So we have the x and the y axis. Here we see x goes from 0 to 1, so from 0 to 1, and y goes from 0 to 2. So y goes from 0, I've already written that, to 2. So this is what our rectangle looks like. And as we know, there's two different ways of computing the rectangle. We have two different orders of integration. So let's first integrate. So let's first do the dy dx. So first we go x, and x goes from 0 to 1. So we get the integral from 0 to 1. That's going to be dx. And then I have the dy, and the y goes from 0 to 2. So y goes from 0 to 2. And then we have the integrand, which is 6x squared y. Okay, let us compute this one first. Okay, so how we do this is I will draw brackets. Usually you do them imaginary, because first we have to do the inner integral. So this is the inner integral, and there we integrate with respect to y. So we have to integrate 6x squared y with respect to y, and remember x is treated as a constant. So so I'm going to leave the integral from 0 to 1, and I'm going to compute the inner integral, which is the integrand of 6x squared y is equal to 3x squared y squared. Remember, if I differentiate this with respect to y, I get 6x squared y, which is what I want. And this is between the boundaries 2 and 0, and then I still have my dx. So this is always my first step. I start with the inner integral. I integrate with respect to y, and I treat x as a constant. And now I just compute this. So this is the integral from 0 to 1. I plug in 2, and I plug 2. Remember, I integrated with respect to y over here. So y is the variable that I plug into. So again, I could write maybe y equals 2. You don't have to write this down, but if you want, this can help you maybe. Just to remind myself that those are the boundaries for y, so I have to plug this into the y. So if I plug in 2 into y, I get 12x squared. And if I plug 0 in, I get 0. So I just get this. Well, now we have to integrate 12x squared. That's easy. That's 4x to the third between the boundaries 1 and 0, which will give me 4. Okay, we're also asked to compute them in the other way. So first, integrate with respect to y, and y goes from 0 to 2. You can see that in the picture over here. Y from 0 to 2, and x from 0 to 1. So we do them now in this order. So we first with respect to y, and then with respect to x, and we have the same integrand. Now let us compute this. So again, I'm going to do the inner integral. So I leave the integral from 0 to 2, and the inner integral is now with respect to x. So I have to integrate 6x squared y with respect to x. Well, remember y is a constant, so this is going to be 2x to the third y. Right? If I differentiate this, I will get 6x squared y. If I differentiate with respect to x. So this is why I know this is correct, and I get the boundaries 1 and 0. I leave the dy. Now I plug in the boundaries. Remember, I've integrated with respect to x over here. So these are all x values. So this is an x value. I will not write the x equals to that, but you can if you want to. So these are x values. I'm going to plug them in for x. So what we get is 2y, and for x is 0, we get 0, so I will leave that. Okay, now it's easy, because this is just y squared, sorry. Y squared between the boundaries 2 and 0, which will give me 4. And we see that the answer we got in the first one was the same as the answer that we got in the second one, as expected. Let us continue to question 2. Okay, again we have a rectangle. Let's quickly sketch it. 0, 1 to 0, 1. So by the same reasoning, it's like this. Now we have to compute them again into two different orders, but they're saying that one of the orders it's not going to be clear how to compute it. Well, let's first try dy dx. So first x and then y. So the boundaries for both x and y are 0, 1. So then we get y e to the power xy dy dx. Let's try this one first and see how far we get. Okay, as I said before, we have to now integrate the inner integral. So it's y e to the power xy. We have to integrate that with respect to y. Remember, x is a constant, so it's going to be y e to the power some constant times y. If you remember this correctly from your first year, the way to deal with these kind of integrals is going to be integration by parts. Yeah, so let's write this here, integration by parts. Okay, so how do we do this? Well, let's do this in blue. Let's say that f of y is equal to y. And let's call g prime of y equal to e to the xy. Then let's differentiate y. We get 1. And let's integrate g. Remember, we have e to the power a constant times y, so if I integrate this, I will get 1 over that constant. So we'll get e to the power xy over x. Yeah, so in this case, this is my f and this is my g prime. Then I know that the integration by parts formula, so you may have learned it with u and v, but it's all the same. So the integral of fg prime is equal to fg between the boundaries minus the integral of f prime g. So if we apply this over here, okay, and first I'm going to keep the 0, 1 and the dx. So in the inner part, I'm going to do the integration by parts rule. So I get f times g, which is f times g, so that's y e to the xy over x. Y e to the power xy over x. Between the boundaries are 0 and 1 of the inner integral. So it's 1, 0, minus the integral of f prime, which is 1, and g is equal to e to the power xy over x. And remember, we're integrating with respect to y. So as you see, I again leave the outer integral part, and I've used integration by parts on the inner part. Okay, well, let's compute this. If I plug in 1, remember this is for y. If I plug in 1 for y, I get e to the x over x. If I plug in 0 for y, I get 0, so we can leave that part. And now for the second integral, I must integrate this term with respect to y. Remember, x is a constant. So it's this by the same reason as over here, when I had to integrate e to the xy, I get a 1 over x extra. I already have a 1 over x, so I will get 1 over x squared. So what I will get is e to the power xy over x squared. Again, between the boundaries 1 and 0. Sorry. dx. Okay, let us continue. So let us leave the e to the x over x. And let us plug in the y is 1 and the y is 0. So if I plug in y is 1, I get e to the x over x squared. Minus, and if I plug in y is 0, I get e to the 0, which is 1. Okay. So what we can do now is, well, we can take the two minuses together. This minus with this minus becomes a plus. So let's do that quickly. So this becomes a minus, and that becomes a plus. Okay, that's a little bit ugly. So you get this integral. Okay, so now it's not clear how to proceed, because, for instance, look at the first term. It's not if you go over your first year techniques, this won't work. You might try integration by parts, but this will only make the term more complicated. You can try this yourself. So I don't know how to integrate this. This can happen in such a question that you come up an answer and you're not sure how to proceed. And then often it makes sense to switch the order of integration. So in this case, it was already said that we have to do this, but sometimes we will just ask you to compute some integral. And if you start like this and you're stuck, you often can try to switch the order of integration to see if the other integral is better computable. So let's try the other direction. So let's first integrate with respect to x and then with respect to y. Okay. So the inner integral, we have to integrate with respect to x, and as I said before, so we have to integrate this thing, and now y is a constant, so by the same reasoning as before, I get a 1 over y, but this cancels with the y that's already there. So we get a very nice expression, e to the xy between the boundaries 1 and 0, dy. So in this case, the inner integral is much easier, so we can already expect this integral is going to be easier. Now let's plug it in. So plug in x equals 1 will give me e to the y, and plugging in x equals 0 will give me 1. Well, integrating this is easy. That's e to the y minus y between the boundaries 1 and 0, which is... Plugging in 1 will give me e minus 1, and plugging in 0 will give me 1 minus 0. So the total is going to be e minus 2. And that is the final answer. And we indeed see that the other way around is much easier to integrate. Let us continue with exercise 3. So here we have a triangular region. So now it becomes much more necessary to sketch it because we don't know how to set up the integral otherwise. So I would always recommend starting with a sketch. Okay, we have 3 vertices. So we have the origin. We have the vertex 0, 1. And the vertex 1, 1, and they form a triangle. So this is my region D. And again, I have to compute it into 2 different ways. That means I can do it in type 1 and type 2. So let's first look at type 1. So for type 1, we need to figure out what are the bounds for x. So x is between some fixed numbers. Let's draw this in green. So we see x is between the 2 green lines over here, which is 0 and 1. So x is between 0 and 1. And then we go for y needs to be below the start curve and above the start curve and below the end curve. So how do we determine the start curve? We basically go up. So this is the starting curve, where y equals x, and then this is the end curve, where you can see that y equals 1, right? So we see the boundaries are y equals x and y equals 1. So this is y equals x, and this is y equals 1. That's the start and the end curves. If you want to do it type 2, we need to first determine the bounds in normal values for y. So let's do that in blue. Well, we can see in the picture that y goes from 0 to 1. Right? So y goes from 0 to 1. What about x? Now we have to look for the start curve for x. So we basically... the start curve here is this one, and this one is the end curve. So it starts on this curve, which is the y-axis, namely x equals 0, and it ends on this curve where x equals y. So it goes from 0 to y. 0 to y. So this is the most important part of such a question. And now we just have to compute it. So let's do type 1 first. So x from 0 to 1, y from x to 1, 8xy dy dx. Computing the inner integral first, so leaving the outer integral. We have to integrate with respect to y, so we get 4xy squared, right? If I differentiate this with respect to y, I get 8xy. The boundaries are 1 and x, and I leave the dx. So plugging this in for y will give me 4x minus, and then x for y will give me 4x to the third. Well, this is easy, because this is going to be 2x squared minus x to the fourth between the boundaries 1 and 0, which will give me 1. Okay, let's also compute type 2, because this was also asked. So in type 2, we first have y from 0 to 1, and we have x from 0 to y. And we have the same integrand always, and now we have dx dy. Doing the inner integral, so let's leave the outer integral, that's the integral from 0 to 1. And in the integral we have to integrate with respect to x. So it's 8x, and remember y is a constant, so it's going to be 4x squared y. Between the boundaries y and 0, dy. Let's plug in the boundaries. Remember, these are for x because we've integrated with respect to x. So we get 4y to the third, and plugging in 0 will give me 0. This is easy to integrate because this is just y to the fourth, which is equal to 1. And once again, we see that the two ways will give us exactly the same answer. Let us continue with the final question, question 4. Okay, we have the following integral, and the first question just asks us to compute this integral. So at this moment, we don't really have to do any sketch. We can just do computation. So let's quickly do this. The integral from 0 to 1, the integral from x to root x, 24xy dy dx. Alright, so again, leaving the outer integral and doing the inner integral, it's with respect to y, so we get 12xy squared between the boundaries root x and x. Let's plug in the boundaries. So root x squared is x. So we get 12x squared. And x squared is x, so we get minus 12x to the third dx. Well, that's easy to integrate. And we get, let's see, we get 4x to the third. And the other one is 3x to the fourth. Between the boundaries 1 and 0, which is 4 minus 3, which is 1. Now question B is a lot harder. We have to sketch the region of integration. We have to switch the order of the integration. So this is a reverse the order of integration question. So let's first sketch the region. So let's see. What do we have in our region? Let's make some space here. So let's see. X goes from 0 to 1. We can see that from the integral. And y goes from x to root x. So now we can sketch this as follows. X goes from 0 to 1. So let's again use green for x. So x goes from 0 to 1. And what about y? So the start curve for y is going to be x, and the end curve is going to be root x. So the curve x is going to be the bottom curve, and the curve root x is going to be the top curve. So the bottom curve where y is x is, this curve over here. That's the start curve, and the end curve is where y is root x, which goes like this. So maybe this is y is x, and this is y is root x. So our region is like this. Okay. This is a necessary step, because in order to reverse the order of integration, we first have to sketch the region, and then do it as type 2, right? This was type 1. So now for type 2, the y variable, we need to find bounds for the y variable. So let's do it in blue again. We can see from the picture that y is between 0 and 1. So y is between 0 and 1. Right? If you compute this intersection point over here, this point, you see that's the point 1, 1, because that's where these two curves meet. X, now we have to determine the start and the end curve for x. So what's going on is we go in this direction from left to right, so in this direction. So this is going to be the start curve for x, right? Where root x is equal to y, that's the start curve for x, and this is going to be the end curve for x, where x equals y. But this has to be written in terms of x, and it's written in terms of y. But where y is equal to root x, that's where x is equal to y squared, right? Because both x and y is positive, that's why in these cases, these two equations are equivalent. So the start curve is where x is equal to y squared, and the end curve is this curve. This is where y equals x, so x is equal to y, because we have to do it in terms of x. So x is equal to y. So this is the important part, basically. And this is the way that we reverse the order of integration. Now we can also compute the integral. Y goes from 0 to 1, and x goes from y squared to y. We have the same integrands, but now the order is different. So we first integrate with respect to x. So leaving the outer integral, integrating 24xy with respect to x will give me 12x squared y between the boundaries y and y squared. Well, let's plug this in. I will get 12y to the third minus 12y to the fifth. Let's go a bit lower. Okay, this is again easy to integrate, so I get, what is it? I get 3y to the fourth minus 2y to the sixth between 1 and 0, which is 3 minus 2, which is equal to 1. And once again, we see that we have the same answer 1 from A as from B. So again, we see that the order of integration doesn't matter. And that is the end of this discussion.